All right, so I've already posted your homework problem. We're continuing to talk about solutions, but we're moving into a new area of solutions now. Recall there were major categories of solutions. One major category was where we always put the amount, some way of measuring the amount of solute over the amount of solvent. And the other major category was where we had the amount of solute over the amount of solution. Solute is the thing that gets dissolved. The solvent is the thing that does the dissolving. Solution is both the solute and solvent together. So last week we were working with molarity, which fell under this category. This week we're working with molality. The symbol for molality is a small letter M. It's sometimes also called molar concentration. And the way that we write the amount of solute in molality is moles of solute. And the way that we write the amount of solvent in molality is the kilograms of solvent. So molality is moles of solute over kilograms of solvent.
How was the weekend today?
It was good. How about yours?
It was good. Actually, we excited.
I went to a wedding in Columbia,
Oh, for real?
and my granddaughter wore me out at the reception. She wanted to dance all the time.
You had to dance with her?
And, well, she danced with me, both her aunts, with her daddy, all the grandparents, and she just wanted, I got her out there first. She was kind of reluctant at first, and then after that, she wanted to dance all the time. She's only 3 years old, you know, so dancing with her is like just, but boy, she slept good that night, I'm told.
That's cute.
Can I get some paper from somebody? Down.
I went to Six Flags.
Oh, wow.
Hey, Mr. Taylor, what is that word right there?
Where?
In front of concentration.
Molal, M-O-L-A-L.
What?
M-O-L-A-N.
Mm-hmm. Like molar concentration last week was molarity. This is molal concentration for molality. Okay? I have to be careful about the pronunciation here and the spelling.
Is this like just a diagram or something?
I don't know.
What do you mean a diagram?
I mean, not diagram, but
It's kind of a flow chart.
Ah.
oh wait, so that wasn't for the homework. Oh, was it?
The homework that I had up here earlier will be what we're going to be able to do by the time we reach the end of this class period. It'll have to do with molality. Okay?
Oh, so this don't go with the homework?
These notes?
Yeah.
Oh yeah, this goes with the homework.
Oh, okay. Okay,
She talks too loud. What does that say? Molality?
Yes. All right. Since we're dealing with amount of solute and amount of solvent, what you want to do is to go through the problem and identify what's the amount of solute in the problem, what's the amount of solvent in the problem. Please do that now and write a fraction down here in which you have the amount of solute as it's listed in the problem over the amount of solvent as it's listed in the problem. Solute is the thing that gets dissolved or is dissolved. Solvent is the thing that does the dissolving.
what is this called? Like, supposed
Solution.
to
Well, we're working with solutions still, but now we're working with some molality.
Okay, so what you want to put at the top?
Solutions. If you want to give it a subcategory to go along, we're actually getting into molality now. If you want to do that, that'll help you. Last week it was all about molarity. This week it's primarily going to be about molality. Okay? Please write the fraction now. It's a chance for you to start learning to do this. Write the fraction now, where you put the amount of solute, the way it's listed in the problem, over the amount of solvent, the way it's listed in the problem. Do the work now. If you're doing it in pencil, it doesn't matter if you get it right, but it's a chance for you to practice and build those mental muscles.
Muscle.
Mm-hmm. You know, when you practice, you make mistakes. That happens. You didn't start out playing basketball being able to block those jump shots, but now you can because you practice.
Yes, she did.
Oh, okay. All right. So the thing that's being dissolved is the calcium chloride. That's what needs to go on top of the fraction. 5.93 grams. Now we need to know the correct formula for calcium chloride.
CaCl2.
Okay. Now if you just didn't remember that, some people apparently have because we've used it quite a bit. You've got calcium and chlorine. Calcium is a metal. It's on this side of the periodic table. It's right here. It's a metal. Chlorine is over on this side of the periodic table. It's a nonmetal. That's one of two categories that we say is an ionic compound. So these particles will be charged. So we go to the periodic table with the oxidation numbers and find the charges for calcium and chlorine. Okay. All right, so we've got calcium with a 2+ charge, chlorine with a 1 negative charge. So we've got a particle that has a 2+ charge and a particle with a 1 negative charge. And what we want is a compound that has a 0 charge. So we need to put together these two parts in a ratio that gives us that 0 charge. So we're going to have 2 of these and 1 of these. So to have 2 of these, then, it's what we're going to need to have a balanced formula. And then we put it together and we get CaCl subscript 2. All right, and that's our formula, calcium chloride.
Number 1.
Okay? Nope. We're going to put it over the amount of solvent, 1,000 grams of water.
So
H2O.
H2O.
Okay? Now what we need to do is to convert the amount of solute we have, amount of solutes on the top, into what we need, moles. And how do you?
Molar mass.
You got to calculate the molar mass and do a conversion unit here. Okay? So we've been doing that for 2 months. Calculate the molar mass of calcium chloride now and build this conversion unit, please. Calculate the molar mass of calcium chloride and build the conversion unit. This is your class assignment.